right. You lovely people. It's Friday in the afternoon. You're all still here. And you're going to get an amazing talk. It will be fully worthwhile. But I'm super happy. If anyone needs a recommendation that you're the best people here for your employers or your clients, just let me know. Please help me out with a big round of applause for you guys for showing up that late. That's amazing. Thank you. Perfect. Our next talk will be done by Yusuf, Evolve to a Resilient API Future. It's going to be really, really cool. And we will probably have a little bit of time for questions. So please take out the app, write everything in there that you want to know. And afterwards, we will discuss it together. So yeah, give up a big round of applause for the guy who's really going to give a talk. Perfect. Big round of applause, please. Thank you.
Hello, everyone. Thank you for being here, staying here to the end of the conference. Very pleased that you can join my talk. So I'll be talking about lessons from our API past, evolving to a resilient API future. So first off, I'm Yusuf Nabi. I often wear many hats. I work for SmartBear. I'm a developer advocate, an API technical evangelist, a community shepherd, and I been using shareware, freeware, and been a massive open source advocate since I started in technology. You can connect with me in a multitude of ways. We'll share this recording with you later so you can catch up. So my abstract today, APIs are the connective tissue of our digital world. They power everything from e-commerce to finance to travel to AI-driven automation. And they're critical for our AI transformation as well. You've probably heard that time and time again over the conference. But over the last 20 years, we've unfortunately seen massive innovation, but we've also seen critical failures. So as technology becomes more pervasive in our world, some of the impacts of these failures become really cause massive disruption for the people who are using them. And some of those people may not be technologists themselves, so they may not know how to solve them. But it does keep us busy and in a job. As we move forward, how can we ensure that the APIs that we build are resilient and can evolve gracefully in an ever-increasingly complex landscape? So what has history taught us about API failures? So the thing to say is we all make mistakes. We are only human, but sometimes we fail to learn from those before us. We always think that we can reinvent the wheel. So I'm just going to look at a couple of types of incidents that have happened. You may or may not have known of them. You may have experienced some of them in your life. So one of the first ones we'll talk about with microservice sprawl is zombie API. So an API can only be managed if you know where it is. If you don't, they can lead to staleness. Your applications may not be updated. Vulnerabilities may creep in. So this particular incident at T-Mobile was due to a legacy app, and the legacy app had an older encryption, and that older encryption was defeated by some hackers, and it caused quite a bit of impact for T-Mobile. Again, on the topic of insecure APIs, we need to develop secure APIs up front, and it can be very difficult. Sometimes you may not know the types of use cases you are opening up in your APIs. Kia found out the hard way. They found out that with a little bit of information, you could misuse their API, and you could actually do things like unlock people's cars with their VIN plate, which is never a good idea. An API communication breakdown. We've all seen kind of the things that have been happening with Twitter and X as Musk went around and laid off lots of people. As you lay off people, you lose technical knowledge in your organization. And if you haven't documented that technical documentation, you can cause impacts to the people that rely on your services. So the company actually released a tweet. They said some parts of Twitter may not be working as expected right now. We made an internal change that had some unintended consequences. We broke something. We didn't know what we broke until we broke it. So the impact of cloud computing, distributed systems, and microservices massively increases API complexity as a whole and the kind of things that you need to think about as you develop your APIs. So if we take a brief little tour of the history of development and deployment, we kind of going from the 1980s, we had the idea of waterfall kind of development process. Everything was in silos. It moved from kind of team to team. Your developers would develop an app. Testers would be expected to test quality into an application, which never works. And we were working with things like physical servers, on-prem systems. The kind of systems we were building were all in one, so it was kind of you were able to maintain some of that mental load in your head. It wasn't massively distributed. But as we've moved forward in the 20th, as we've moved forward now into the 2010, we've moved to Agile and Agile DevOps. Teams are being asked to own more, not just the development process, but the development all the way to deployment and monitoring the application after. And we're working in an increasingly fragmented landscape. So we've got cloud services, and we're working with, we're still taking our same type of applications we used to package in monoliths, but we're now doing them in microservices. If you imagine this is the same application, we now have a huge number of components on the right, and we're still doing the same thing. And each one of these representations of these lines is a potential failure point. So when we think about more microservices, what does that actually mean for the industry? So some industry stats showed from a State of API report from last year showed that 61% of practitioners are seeing API growth coming from microservices. 81% of those companies are working in a multi-protocol environment, so they may be using REST services, event-based services, third-party integrations, and actually 57% or more are using 3 or more protocols. And these pictures on the right, I think they're from about 15 years ago. They show the complexity of these systems at their very early age. So this is what we commonly refer to as service Death Star. There are around 500 services here. So if you imagine you're trying to keep that kind of knowledge in your head when you're going to propose a change to an API, you're very quickly going to exhaust your mental model of what you can fit in your head. And this leads to some headwinds, and these headwinds are often referred to as microservice sprawl. So some of the barriers to actually implementing these microservices are lack of experience or skills. If you've not worked in a microservice architecture before, some of the previous kind of tools and techniques that you use may not apply. And these systems are massively complex. And whilst they are complex, the users have ever-increasing demands on your services. They expect much better, interconnected experiences. They want to continue the same journey on their mobile, on their desktop, on their iPad. And they are much more likely to vote with their feet and go to a competitor if they have an issue. So you can imagine you're getting product owners and things breathing down your neck, trying to increase the demands on your speed of delivery. And in general, you may find that there's limited time due to workload. So some things are naturally going to slip as you take a risk-based approach to delivering your software. And I actually started my career, I did artificial intelligence and cybernetics at uni, but I ended up doing a placement in accessibility testing, and I was able to go into a bank and see a grown man cry because I was able to get him back to work because he had a visual impairment. So the testing we were doing was not only bringing joy to people's lives, it was enabling them to get to work and do things. I mean, imagine, when you've all had a really bad experience with software, it doesn't bode well. So when we think about the testing challenges of these interconnected systems, it isn't just big organizations, small organizations feeling the pain. So this is a particular quote from our customer. He's operating in a very large program. He's got different Scrum teams. They're all trying to develop at different rates. They're in a microservice-based architecture. And they're actually finding that their testing today is highly volatile. They've got a set of integration environments, and they're finding it very challenging. And they want to get better confidence, and the way they're going to try and do that is using isolated contract testing, which we'll talk about in a bit. But they're saying we've got RESTful calls, GraphQL, we've got AWS EventBridge, Kafka, and they've also got those third-party integrations. So that idea of this customer is that one who's using those 57%, 3 or more protocols. So why do I care about testing, and why should you care about testing? So Let's just talk quickly about the role of testing. So we've got testing for a few reasons. We want to make sure that our user goals are met, our systems can interact correctly, but they also add additional benefits. They provide stakeholder confidence. Your product owner likes seeing the green tests. They provide living documentation. These tests will describe how your system works or how you expect your system to work. So if one quote one friend said to me was, always maintain your code as though the next person who is going to look at it is a psychopath who knows where you live. So that living documentation is absolutely brilliant. And then there's kind of risk mitigation measures. So your organization will try and limit the loss of revenue, damage to their reputation, litigation, and if you're in safety critical software, the loss of life. So when we think about the old way of testing, we might think about integrated testing. And integrated testing, when we consider it with microservice architecture, we actually find that it's very, very slow. It's hard to maintain. It's unreliable, flaky. It's difficult to fix. It doesn't scale as teams grow. And you're actually only able to find bugs late in the software development process. So a well-versed QA engineer or someone who's working in quality, when they find a defect, they will try and identify if they can deal with that defect earlier in the SDLC. The cheapest bug you'll ever fix is code you've never written. An end-to-end test, when we think about end-to-end tests, they may be driven by a browser, and they normally traverse every single part of your system. So when you have a failure, it's very hard to identify where that failure occurred from. It's a very large haystack. And it's hard because it's slow, it's fragile, it's hard to debug. You end up with all-at-once painful deployments. And teams end up waiting on build queues. And as you increase the amount of teams and components in your system, it actually becomes incredibly difficult. So this would be a perfect kind of line that we'd like to see as we increase our teams and components. It's very stable, but actually when we think about when we're trying to do integration testing, we end up with more teams, more teams and more components. We end up with more environments. We end up with longer build times. You're waiting for these end-to-end tests to execute before you can deploy your changes. There's a higher risk associated with that change. And you end up with developer idle time. They're sitting there waiting for services, CI systems, etc., to be able to have free agents so they can run their code. So as I said, I came from a testing background, so I like to think about things as a testing pyramid. It's not perfect, but it's a good way of kind of framing the value that you get from testing. So at the bottom of our pyramid, we have unit tests. You kind of have a larger amount of unit tests. They're very quick to write. They give you a very quick feedback loop. They're very low effort to write. They are very dependable because you control a lot of the parameters in those tests. But actually, we get very little confidence, or we get a small amount of confidence. As we move up this test pyramid, we begin to get much greater confidence that our system will work together. But we see that as we move up this testing pyramid, they actually become more and more costly and fragile. We have to wait for our systems to be developed before we can actually run these tests. So how can API specifications like OpenAPI or async API serve as a bridge between design, implementation, and governance? So how can we use API descriptions to kind of talk the same language about our interconnected systems? So API specifications have there's been several, but over the last kind of 10, 15 years, two have really emerged as leaders in the pack. So there's OpenAPI, which is for RESTful services, and async API, which is for event-driven services. And async API has lots of different drivers for, Kafka or RabbitMQ, etc. Now, the reason these specifications are so important is because they can form both human-readable and machine-readable documentation, and they can actually be used in many different parts of your SDLC. So you can, generate SDK clients, or you can generate your server code. You'll probably have to modify it a bit. You may be able to generate tests off the back of your OpenAPI specification. But they're not the silver bullet. There are still challenges with open API descriptions. So some of the challenges we're going to talk through today. One of them is provider drift. Provider drift is where an API implementation does not match its description. So if you've ever gone onto a developer portal and then you fired up your favorite REST client and you find out that that API doesn't behave as it's documented, you're not going to be a very happy bunny. And actually, if you have a monetized API, it's the quickest way to alienate prospective consumers. There is some open automated API testing. There was API's Dread, which has now been deprecated, but Schema Thesis is one of the leading that will take your open API specification and automatically generate tests that you can check that your implementation matches with that documentation. This normally applies for spec-first development if you are using if you're using like annotations in your code to generate the open API specification, you can be very confident that it's actually going to match with your implementation. Now, many people say to me, I've got an API description, that's my contract. That is how people are going to use my service. Now, I work on an open source project called Pact, and one of my co-founders of the PactFlow project, he mentioned that schemas are abstract and contracts are concrete. So we believe that a provider contract, something that someone will say, my API will act like this, is only valid if you have your API description and you have some kind of functional testing that shows that you have your API implementation actually matches that description. There was a advertising campaign by Ron Seal called Woodstain. There was an advertising campaign for a product by Ron Seal called Woodstain. Their marketing campaign does exactly what it says on the tin. So I advocate for you to build APIs like Ron Seal. Make sure that your API description does exactly what it says on the tin. But your provider contract is only one representation of your API. Hurum's law dictates that with a sufficient number of users of an API, it does not matter what you promise in the contract. All observable behaviors of your system will be depended on by somebody. The question is who, and there's a brilliant XKCD number 1172 that shows every change breaks someone's workflow. Now, consumer drift is where Hurum's law comes into play. So without a clear view of your consumers and what they depend on, it actually leads to testing bottlenecks and big bang deployment. So the testing bottlenecks come from the majority of the testing has to take place in integrated environments, and that gives you very slow feedback loops. And actually, if you've only tested your system in an integrated environment, the only way that you can really safely and confidently deploy that system as a whole, is to deploy everything, a big bang deployment. Now, if you imagine you've got 500 microservice architecture, doing a big bang deployment is going to be painful. Versioning, everyone's favorite subject. How do we actually determine whether the change that we want to make to an API is a major, a minor, or a patch? How do we deal with multiple code paths to support multiple versions? It increases the complexity. And when we actually, there is some automated tooling that might look at a previous specification and the new one and say, well, this is the version number, but does it actually consider if it is a break and change to your consumer or not? Because this API specification doesn't show how consumers use your API. And if you have public API consumers or IoT devices which may not be able to be updated, you may actually update your API, break them, and you'll never know. But break and changes are a part of life. Very few people craft the perfect API up front. So APIs will need to change, so we'd like a way to be able to manage these. But if we're unaware of the consumed surface area, we can't determine those impacted users and apply an appropriate semantic version, which limits our ability to propose effective change mechanisms, like expand and contract. It stops us from adding safe extensions to our APIs and the ability to deploy independently. And Beth Scurry, the creator of the Patch Broker, said, if you can't deploy your microservices independently, you've built a distributed monolith, which is literally the worst of both worlds. In order to Open API and Async API are great at describing their respective protocols that they cover, but they are not good at specifying the rules that are pertinent to your organization. So if you imagine you're an API architect, you've got 100 teams that you look after, they're all generating APIs. They say, we want autonomy, you know, teams are developing stuff in different languages. How do you ensure you get the same type of APIs built in your organization? So standardization and governance is key for the rules that are important to your particular organization. The standout tool at the moment is something called Spectral. Either Spectral or Vacuum. They both are open source projects. They both use Spectral rule sets. So Spectral is really coming out there as the leader in this standardization and governance. Spectral works with both OpenAPI, Async API, and a new workflow, which we'll talk about later, which is called Arazo. So now that we've talked about some of the pains that you might experience with microservices, how can we use something called contract testing, and in particular, packed and packed flow? But contract testing is a technique, not a tool. So you can apply this technique on your own without the tooling that I'm talking about. And why does it allow safe API evolution, compatibility, and long-term stability? So as a tester, I like thinking testing quadrants. It allows me to kind of think about all the types of testing that are there and what I need to do in a risk-based approach. So contract testing sits on the top left. It's business-facing, and it helps guide your development. So what actually is contract testing? So if we think about integration testing, and we're thinking about a smoke alarm, would you set your house on fire to test your smoke alarm? You might do if you're a pyro, but you probably don't. There's a test button on the smoke alarm for a reason. So that's this idea of the contract. You press the button, the contract is with the ears, the alarm goes off. So Pact provides this testing button for your code, allowing you to safely confirm that your applications work together before you deploy them, and you end up with everything is fine fire. Now, contract testing has been around for a while. 2006, Martin Fowler and Ian Robinson from ThoughtWorks proposed it as a service evolution pattern. Now, many people, when we're thinking about that test pyramid and we're trying to move things down the stack, we might look at our integration testing. How can we move that type of component integration testing further down into kind of the realms of unit testing? So what we might choose to do is mock out our provider. When we mock out our provider, we got all those great unit test benefits of running independently, fast feedback, they're very stable, they're easy to maintain, but we don't have confidence to release. The reason why we don't have confidence to release is that mock that we're using might actually drift from reality. So Pact helps us on the consumer side by working with your unit tests. It provides that mock provider, and when you run these tests, a JSON file is output that neatly summates all of the expectations from that consumer and the provider in order to say, these are the things that I need to call in order for my system to work. Then on the provider side, a provider is able to pull down all of the contracts, and the Pact framework will replay them against a running provider. That running provider will return a result, and it can be compared against the expected result from the consumer. If the provider is able to meet all those contracts, they know that we can safely say that these two applications will be able to communicate in real life. So when we look at our test pyramid with contract testing, it sits a little bit above unit tests, but below integration tests. So we're actually going to run these tests pre-deployment. And the benefits of contract testing, it's much simpler. We can test a single integration at a time. We don't need dedicated test environments because we're doing this before we've actually deployed to a particular environment. We get tests that scale linearly, so we get that nice line, and we get to deploy services independently, ultimately saving you time and resource costs, which means you can help deliver those business outcomes that your product owners are crying for faster. So once you've got your contracts, you need somewhere to store them. So we have an open source project called the Patch Broker. It allows you to store your contracts. So here we can see the consumer and provider. We can see when the latest contracts were published and when they were last verified. And that allows us to query the Patch Broker anytime with a particular version of a service and ask if it's safe to deploy into a particular environment. A patch contract looks like this. So before we said schemas are abstract, contracts are concrete. This is a concrete representation of that contract. And it also allows you to visualize your very own microservice Death Star. So how to actually work in practice. A consumer will run their tests. That will generate a contract file that they'll publish to Packflow. They will then run a tool called Can I Deploy, and they will find out that the provider has never verified that contract, so it's not safe to deploy. So at some point, the provider can implement that feature. They run tests that will pull down all of the contracts that they relied on. They will then verify them and publish the results back to the patch broker. The Can I Deploy tool will be run again on the provider side, and the provider is safe to deploy because they are able to communicate with all versions of the consumer. And from the provider side, they're able to run their tests, publish a contract, Can I Deploy will now pass, and they're able to deploy that safely into production. That particular verification was done by doing it against a running provider. You might be using spec first, so you already have an open API description. To reduce the barrier of entry, there's something called bidirectional contract testing. So there's an open source tool that will compare a contract file and ensure it's a valid subset of an open API document. SmartBear acquired the Pact open source project about 3.5 years ago. It's why I now get paid to play on open source. It makes me a very happy boy. If anyone's ever seen the Swagger editor, it now has, well, the hosted Swagger editor, backtrack slightly, the commercial Swagger editor now has the capabilities to run your contract tests at design time. So I could make a change to my API, I could find out exactly which teams I'm going to impact, and maybe I might change the way that I design that API, or I can go and have a really targeted conversation with those teams. And I don't know if anyone here has ever sat in a meeting with a provider about a change that will happen, and when you go back and look at your code base, you realize you've just wasted an hour in that meeting because it has no relevance to you. It'd be remiss of me not to talk about AI contract testing. A lot of people say there's a large barrier to entry for contract testing, so AI contract testing is now available. We use the context of your OpenAPI description or your code under test, and it's been preceded with kind of 10 years worth of contract testing knowledge. That's being evolved to also apply reviews for your code as well, to ensure that the contract tests you write are following the recommended framework. And I'll be finishing off with talking about, you know, we've seen here from pretty much every stall, there's something about AI and people talking about agentic workflows. The emerging world of agentic workflows and AI is going to cause some complexity. So the OpenAPI initiative, they've been working on something called Arazo. So Arazo is going to allow us to compose deterministic API workflows that can drive complex orchestrated system interactions. So test pyramid again, top of the test pyramid is going to get us the most confidence, but driving a browser is costly. We can think of subcutaneous testing. So this is driving your user journeys without actually using the browser. So it's looking at the API calls that compose those journeys. And agentic consumers will actually proliferate. They'll very quickly become the most prevalent API consumer. So I've told you about pain people have experienced with humans developing services and other humans developing services. What's going to happen if you don't know those consumers? What's going to happen in a world where you've got millions of consumers and, you know, they're robots? So Arazo has recently been introduced tail end of last year with the OpenAPI specification. It became 1.0 a few months ago. It describes an approach to document use case-orientated workflows. I won't read these use cases. I'll just show you a nice picture. So you may all be familiar with YAML if you've written an OpenAPI description. It allows you to describe the workflows, inputs, parameters, etc., the components, reusable objects, and assert different flows. And these API specifications allow you to build both machine-readable and human-readable documentation. So it allows you to build things like this. So on the left-hand side is a completed Arazo document, and on this right-hand side is a visual representation of the flow. So if you imagine you've ever seen an architecture diagram in your organization and then gone back and looked at it and like, that doesn't quite match up. So as you amend these Arazo specifications, you get living documentation that matches your systems. So Hurum's law, use contract testing to enhance your existing component integration tests, give providers visibility into consumer usage, and allow them to understand the impact of consumers so they can make better, more informed changes. And by using contract testing as part of your microservice and API delivery strategy, you can use expand and contract and safe extensions to deal with breaking changes. You can deal with provider drift by ensuring that your API descriptions match your implementation. You can deal with combat Hurum's law by understanding who's using your services, ultimately reducing the need for versioning, reducing code paths and provider complexity, and ideally, with a clear view of our API usage, we can live in a version-free API world. So thank you very much. That's my talk.
Perfect. A big round of applause for Yusuf, please.
Thank you very much. And if we have any questions, if we've got time.
We don't have any in the thing right now. Does anybody have one? OK, no questions. We're already perfect.
It's absolutely fine. I totally appreciate it. It's the end of the day.
Yeah, and Yusuf will be on the side, like if you have any questions.
I'm also available in a multitude of different ways. So if you ever want to contact me, you can just email devrel@smartbear.com, and we're always available.
Perfect. Everyone, thank you very, very much for sticking. A big round of applause for Yusuf for this amazing talk. And there is going to be one more big talk at the main stage, 5 things in tech that matter we have to make work. It's really recommendable. We see each other there. And get home safely. Thank you very, very much for coming. And I hope you enjoyed the We Are Developers conference. Thank you.